Welcome to the New Look Train Talk, and we're taking you higher, wider and deeper than ever before, aimed specifically for drivers as we talk with the experts about what's going on around the metro system, internally and externally, and what's going to impact you.
G'day, I'm Anthony O'Caro. I'm a signal sighter and route specialist with Metro Trains, and I'm also a qualified driver. Today we're going to talk about Blackburn and the grade separation that's been underway. As you can see, we've got new overhead, new tracks, improved points, improved drainage as well.
The Blackburn grade sep followed a theme of early on in the project we relocated gas, water, major drainage, electricity, telecom, so Telstra and Optus, and also the rail services, so all the signalling services, the HV assets. We relocated all of them to essentially allow the construction to take place. So the main aim of the Blackburn grade separation is to really provide a safer network by reducing congestion on the road, so you reduce that rail road interface by removing the level crossing. And that's the ultimate goal of the grade separation projects.
One of the first things that drivers will notice is that there's new signals at 304 and 308. These have been converted from automatic signals to home signals. The signal on the left, that's 304, and the signal on the right is 308. Another thing that drivers will notice is that all the signals here at Blackburn have been upgraded to LED.
And the outcome of that is now that we've got improved visibility and safety for the signals. The LEDs are predominantly more visible, as well as the maintainability of these is much better.
Here we are at one of the home signals at Blackburn. As you can see, it's been upgraded to an LED. We've had the signal sighting committee come over and ensure that the sighting and the focus of the signals are optimal for driver visibility.
So the committee is made up of representatives of signals engineering, human factors, maintenance, drivers representatives from both Metro and the other AROs that use our infrastructure, and train services. In practice, that translates to input at the design stage for the placement of signals, through to the configuration of signals at the construction stage, and then the fine-tuning and focusing of signals at commissioning. So the committee helps with the drivability of sites, both greenfield and brownfield, by identifying opportunities to maximise the signal sighting within the constraints of both the physical and the operational layout.
Signal sighting has a huge impact on the signal placement in the project, as well as other contributing factors like operations, need for train placement, as well as headways are the main factors that we consider. So with the signal sighting specifically, we're really looking at trying to get the best sighting and ensure that we have compliance with safety requirements.
The Blackburn project and what it will look like in its final state when we hand over will be essentially a long cutting from the downside of Blackburn Station through towards the Nunawading end. Essentially, you'll see yourselves going through and under 3 bridges. We'll have a Blackburn Road Bridge, Cottage Street Bridge and Oliver and King Street Bridge is one of the deeper cuttings that we will have done on the grade separation projects. And as you go through in both directions, you'll sort of see the long linear uphill or downhill run, depending which direction you're going.
The points at the down end of Blackburn have been upgraded, and drivers will note that there's a new gradient that will lead you underneath Blackburn Road. This gradient is 1 in 49. Coming out of Blackburn Road, it is 1 in 40.
So with Blackburn specifically, we had challenges around the non-compliant grades that existed in the area. So to bring everything up to compliant meant we had to chase the grade up the dig into the cutting. So that elongated the whole site by a significant amount. And that's why Blackburn is around a kilometre long project.
Drivers will also see new lifts that will be built on platforms 3 and platforms 1 and 2. Also, there have been minor adjustments and improvements to the platforms.
The lifts will provide compliant DDA access to Blackburn Station and also provide a bit more connectivity through the station.
The controlling signaller here at Blackburn has moved and is now at Ringwood. So if drivers need to contact a signaller, it'll be at Ringwood.
Now we've integrated it with Ringwood Control Room alongside the upgraded control room that was done as part of the Bayswater project.
As you probably know, the speeds haven't changed. We do have a 65k speed coming into Blackburn from the up direction and 80 k's on the down direction. And now we're looking at commissioning early February. Hi, today we're talking about Heatherdale Station and the grade separation here. The first thing that drivers are going to notice at this job is how deep the cut is. A substantial amount of soil has been removed to achieve the 1 in 40 grade that enters into the station to improve the drivability of this location.
There was an existing cut that was in Heatherdale, and we've actually expanded that cut further down. And one of the major parts is we've also, with that, relocated the station and taken it off the bend and onto a straight on the downside of the new Heatherdale Road. The added benefits of this is that we now have a straight platform. It also lets us interface in with where the road is, and it actually saves us a fair bit of time with the construction, as it's been able to allow us to do a fair bit of the pre-build. Out of it, we'll have a new Heatherdale Road bridge and also a new bike bridge at Purchase Street.
So the location of the signals have changed due to the move of the station. We've kept it all automatic signalling in the area, but we've enabled some additional operational flexibility by letting trains in certain sections.
Another substantial improvement is how the station is designed. As you can see, the platforms are 160 metres long and they're quite level and easy to drive through. We've improved the signalling through here with new LED automatic signals throughout this section, and the speed remains the same as per normal at 80 k's an hour. Another thing that drivers will notice, we've got new lighting here, non-reflective surfaces and a nice level platform. This platform is DDA compliant and has been designed for drivers.
At Heatherdale, signal signing has a large impact on the actual positioning of the signals. So we've gone through from the start of design to the end of commissioning and involved signal signing committee to ensure safety.
The primary function of the Signal Siting Committee is to provide advice and support throughout all stages of any changes to our infrastructure to ensure optimal visibility of the signals. In practice, that translates to input at the design stage for the placement of signals, through to the configuration of signals at the construction stage, and then the fine-tuning and focusing of signals at commissioning. There's 4 basic pieces of equipment that we use. The first one is a measuring wheel. We use that to measure out the minimum sighting distances and the optimal sighting distances that we use. The second one is a laser measure. We use that to measure clearances. We use binoculars for looking at signals long range to help with focusing. And probably our most important piece of equipment is a periscope, which allows us to see signals from a driver's eye line without having to actually use a train.
Signalling and overhead have an inherent relationship in the design. From the start, we've always had a very close relationship with them to make sure positioning of air gaps and certain infrastructure is not impeding the signalling and works with the electronics. So the positioning of the air gap was very predominant in where we had track circuits and signals lie, because you have to have a certain safety margin between where those are positioned. And that was a huge challenge with respect to trying to make sure we had the right headways. So we've mitigated a lot of that by getting the signals in the right position and moving air gaps into spots where they actually fit. And all that, we need to ensure that maintainability of the area is still up to scratch. So the substation challenges that we faced were focused around a lot of the old infrastructure and what we could maintain and what we could not. The biggest problem we faced was being able to construct it in the time frame we had, as well as mitigating the dirty power supply issues we have in this particular group. So that caused a few issues on previous projects with signals specifically. So we've managed to get through that by putting specific circuitry into the signalling to clean up the power.
Drivers would observe work commencing here September 2015. In December, we've had occupation and we plan to commission in February.